Hello and welcome to this DCD Talks, powering high density innovation with liquid cooling. I'm Alex Dickens, Content Director at DCD, and it is my pleasure to be introducing Peter Huang, Global President for Data Center Thermal Management at BP Castrol, who is coming to talk about this topic. How are you doing, Peter?
Doing great. Thank you, Alex, for having me.
Well, thank you very much for jumping on. Peter, perhaps by way of a little bit more of an introduction, I've given the top line intro to you, but would you be able to introduce yourself and your role at BP Castrol in a little bit more detail? What did your day-to-day look like?
No problem. So I manage the BP Castrol data center thermal management business globally. We have a global presence across many different regions. Our core products revolves around fluid, liquid cooling, and services. We have a very diverse portfolio because we're not simply just a fluid provider. We're a liquid cooling orchestrator. We're trying to integrate end-to-end solutions. We have hardware, we have accessories, and more importantly, we're trying to reduce the barrier of entry for liquid cooling. So we're involved with a lot of service partners globally, and also regionally. Last but not least, we try to leverage our global supply chain and our technology know-how for the past 126 years where Castrol has been, trying to innovate fluid. So that's where we are.
Fantastic. Brilliant nutshell summary. So, as you say, you look at everything end to end, and BP Castrol has this incredible global view. But when it comes to liquid cooling, if we take a step back, I'm keen to understand the adoption trends we're seeing when it comes to these technologies. How are BP Castrol seeing, the uptake in liquid cooling solutions?
Thanks, Alex. So as you can see, they're all over the news. People are investing hundreds of billions, thousands of billions of dollars into AI data centers. Keep in mind, AI data center equals to liquid cooling. And the reason why is because when we go up to higher power density, higher rack density, liquid cooling is not even an option. It's a must, right? So it's a trend. It's a must trend that we're facing right now. We see a massive acceleration, in AI HPC workload that accelerates liquid cooling and accompanied with the rack density. However, in some spaces and some smaller operations and retrofits of brownfield data centers, the adoption of liquid cooling, does face some barrier of entry. So we're seeing that hyperscalers or large cloud providers, service providers are adopting liquid cooling left and right. A lot of investments are planned down to the next 3 to 5 years. Our customer has showed us the pipeline. We have engaged with them commercially, technically, so we know that it's real, it's happening. Mm-hmm. But on the other side, enterprise accounts, co-location customers that are smaller in operation may adopt more of a hybrid solution. And their adoption, the barrier of entry are a bit higher because, as you know, traditional air cooling is more dominant still today, but liquid cooling is definitely picking up. We're seeing a 70-30% split between air versus liquid. So yeah, that's generally the trend right now. But I wanted to mention one last thing, which is very true, is that liquid cooling does reduce OPEX, energy consumption of cooling, by up to 30-40%. And it's actually proven that you can achieve a lower PUE, power usage efficiency. So yeah.
Fantastic. And as you outlined, there's different trends happening depending on different types of operators. I'd like to dig in a little bit to those barriers to entry you mentioned. In particular, what other bottlenecks exist around liquid cooling deployments, especially for those who perhaps haven't had liquid in the facility before?
We can view this, Alex, in many different aspects. Okay. I'll start first with the core components. Liquid cooling comes around with a lot of new components and supply chain that's very different from traditional data centers. You have to start first from design. So your thermal design versus traditional server IT design is very different. Now you sort of have to integrate mechanical thermal design with IT design. So first, that's the design part. You need to have a standardized design. But in the world right now, there's not much standard design. There are designs associated with key chip manufacturers or key server OEMs, but the server itself does not dictate the whole data center design. Server is one design, and then you have infrastructure design. So I would say the first one is a design barrier of entry. Obviously, with that comes with people, operation expertise, design expertise, service expertise, commissioning, operation expertise. That's all part of the design part. Now we go to supply chain. Supply chain is also a limitation, you know, attributes to the barrier of entry. For example, liquid cooling has a lot of specialized components: cold plates, pumps, quick QCD, quick connects, manifolds, piping. There are so many different options right now in terms of how you design your infrastructure, and supply chain lead times right now are crazy. We go to the market trying to source something, the lead time is really crazy. So designing, you need to standardize. Supply chain, you need to limit the lead time, but also standardize your supply chain. There are two bottlenecks that we see. The third one is more on industry-wide standards and policies. So now you're on liquid cooling. One of the worst is liquid. So how do you deal with the dielectric liquid, the water-based liquids, the compliance with local regulation, environmental regulations, policies? These have not really been defined well in terms of globally or regionally. US is probably the most advanced in terms of how it governs OCP standards, ASHRAE standards, but a lot of places in the world, this is still up in the air for people to really have a clear understanding. Last but not least, for people who have some information gap, that will feel like liquid cooling is more expensive, capex-wise, which is true, okay, but the total cost of ownership for liquid cooling actually compared to traditional air cooling is actually more favorable over time. But you do have to pay more of a premium upfront. We are, as a key participant in the industry, we do see that the premium is going to go down slowly as the industry and the technology matures. But as of today, it is more premium than air cooling for sure.
Fantastic. And to change the subject a little bit, one of the topics we're hearing a lot in our cooling conversations here over at DCD is how different operations are planning for the future. With AI hardware evolving so quickly, how are we thinking about flexibility? When we're deploying liquid cooling today, how can we make sure we've got our forward plans, with adaptability embedded into it as well?
Thanks for the question. That's a great one. I want to start off with an example. Our approach to accelerate liquid cooling is we design for scale. We design for proof of concepts. So we wanted to gain the confidence from the customers. So we have to design for scalability starting from small, and then we try to do it in a proof of concept stage where it's not going to impact a lot of the load. Because ultimately, the data center cannot be disrupted. The customer's data need to be secured, protected, uninterrupted. So we want to start small, but have the ability to scale. Once we do that, we prove the concept that is actually working. We actually need to adopt a modular design around it. What does that mean? That means you have blocks. You have cooling blocks, electrical power blocks, and then IT blocks. When you have these type of blocks, you're able to design and ensure a standardized interface. Instead of, I'm trying to put in a whole bunch of racks, a whole bunch of cooling equipment just for the sake of it, and high capex. So we try to do it modular, we try to do it scalable, try to do it proof of concept. So that's the three things I want to mention. Last but not least, which is our expertise, where we play, is the fluid compatibility. Alex, as you know, chip generations, server generations, AI workloads are increasing faster than the speed that we have ever witnessed. Before, a chip or a server comes out that you can do these type of workloads for the next 3 to 5 years. But now we have a new version every 6 months. Less than a year, we have a new version. So we have to plan for liquid cooling compatibility across generations. And not just fluid, but the whole component revolving around the fluid. What's the next generation of chips that you're going to deploy? Customer needs. What's the next generation of GPUs or servers that you're going to deploy? So we have to design around it. Compatibility for the future generation, build the extra power and cooling headroom for the buffer that enable you to scale. These are the things that I would really consider for future proofing.
Fantastic. And you touched upon a range of different, parts of the kind of liquid cooling ecosystem there, which is something I'd like to drill down into a little bit more. You mentioned at the top of the session, BP Castrol, you pride yourself on having these strong ecosystems, and you mentioned here, chips, power, all these different aspects you need to think about, in relation
Mhm.
to liquid cooling deployments as well. I guess from your perspective, could you please elaborate, for you at BP Castrol, what do, kind of good ecosystems of technology mean to you? And how are you working with your partners to make sure that liquid cooling deployments are as good as they can possibly be?
Thanks, Alex. I wish I can show you a graph, but I'll try to explain it. So imagine a data center coming from the very upstream, which is coming from the chip. The chip is going to integrate with the servers, and the servers is going to have more than a chip. You're going to have memories, you're going to have DRAM, you're going to have power shelf, you're going to have cables, switches, all that stuff. And then from the servers, you integrate the server into a level 12 or level 11 rack. The rack needs to be liquid cooling ready. It needs to have all the components like piping, manifolds, pumps, QCD installed on it. After the rack, you need to design your infrastructure around the racks. Okay, your cables, your CDU, cooling distribution units, your chillers outdoor. And then right after that, you need to integrate with the other components such as switchgear, transformers, IT loads, and the actual fiber optics cables, switches. So all that stuff is from beginning to end is a complete ecosystem. Okay. We are proud to say that we probably is the most integrated fluid provider, liquid cooling provider in terms of the whole value chain. The reason why I say that with confidence is because we have people and technology people working on all aspects. Starting from the chip and the servers, this is very fundamental server design, thermal design. All these, you need to test TDP, you need to test heat conductivity, you need to test fluid compatibility, mixability, performance, and then you need to scale it. Meaning, now you have a rack that's 50 kilowatts. What if tomorrow I want to go to 100 kilowatts, 150 kilowatts? What's happening to the pumps, the valves? Can we run it for a long duration? All these needs to be built within something we call a reference design. The reference design builds the confidence within the customer, but also the confidence in your certificate with the OEMs, the server OEMs. They are able to give you the warranty for it. That's very important. You buy a very expensive millions of dollars of servers, you need to have the warranty. Now you go to the infrastructure levels. Ensure that whatever design options that you choose, right? You're in the UK. The UK design is very different from Malaysia design. India design is very different from US, Ohio design, right? So all these design factors is going to change how you design your infrastructure apart from the racks. UL, CE certificate, IEC certificates needs to be regionally and globally safety standard, fire prevention standards, and people call leak detection, making sure it complies with the regulations. All these standards are part of the design aspects. So we have a lot of people working on that. Okay. We have partners. We have portfolio companies within BP Castrol that works on these. We have OEMs and ODMs that build for us. Okay. And we actually don't build for today. We build for tomorrow. So just using NVIDIA as an example, today we may see GB300 as the trend. We're building for Rubin Ultra, for example, 2 years down the line, because we know that's going to be the trend moving forward. So that's a key overview of ecosystem. But something that I didn't mention, I want to mention at last, is services. People often overlook, okay? It's not like I put in a CapEx, but this thing has to operate for the next 10 to 20 years. So what if it leaks? Okay, what if the fluid leaks, which is the biggest worry and biggest risk that people talk about the most? So one of the things that we specialize on is something called leak detection and sensing sensors. Essentially, it serves two purposes. One purpose is to detect if the fluid is leaking. So it protects the very expensive servers. This is actually very industry standard. I wouldn't say this is a very specialized, but what I wanted to mention next is actually very specialized. It's actually called fluid analyzer. Let me elaborate more. If you use a direct to chip liquid cooling, you typically use a propylene glycol PG25. You have a PG level and you have an additive level, right? People oftentimes, when you measure your fluid, you measure the PG level, the propylene glycol level, which is like the antifreeze, okay? Which is, you can view it as an antifreeze. You make sure that it is within 25%. Typically, every vendor, every customer, every solution integrator, they do it. But what we do differently is we actually have a sensor and an analyzer that monitors the actual additive. So even if the PG level is 25%, that doesn't mean your fluid is healthy. It measures everything beneath that superficial surface on your additive. And you can view it as, you can look at a person, you see the health of the person, but you actually need to test their blood. We're actually testing the blood and the DNA of the fluid continuously. And it's the inline monitoring, which is very standardized in OCP standard. Last but not least, I wanted to talk about calibration. All these liquid cooling systems needs to be calibrated regularly, right? You run it for a while, you need to people go there to manually calibrate it, which is what they do normally in annual maintenance, preventive maintenance. But in liquid cooling, do you know how many days you need to calibrate your sensor? Typically 1 week. Every week you need to calibrate it once, okay? Usually. Our sensors, with the solution that we're deploying right now, are automatic calibrated. So that's why it's really special. And yeah, I just wanted to mention that it's we're trying to approach it as an industry standard, and we're trying to build more partnerships into the ecosystem. And obviously, it's all for the benefit of adopting liquid cooling in the industry. Yeah.
Fantastic. And we're running down the clock, unfortunately, Peter. But I'd like to sort of wrap up by asking for newer adopters as well. We talk a lot about those which are kind of AI scale data centers or hyperscale or big colo facilities. But for operations which are looking to kind of enter into the liquid cooling market now. We've spoken about a huge range of considerations and factors and barriers to entry. But from your perspective, what should we be thinking about, first and foremost when we're thinking about the types of technologies? It's a conversation as you've gone into detail. It goes beyond a choice of cold plate or immersion or hybrid. There's fluids. There's so much to it.
I think it's a great question. There's no right or wrong answer, Alex. It would be going back to the drawing board and looking at what do you want to achieve? What do you want to achieve in your data center? Is it more cloud computing? Is it more HPC? Or is it more inference for training, right? Is your customer an enterprise or is your customer more of a hyperscaler? It really depends, all right? But I would say right now, the technology choice and the main trend right now that you're going to obtain a lot of OEM approvals is cold plate cooling. Okay, cold plate cooling is the trend right now. It supports up to 100 kilowatts per rack, close to even 200 kilowatts per rack. And then people are looking at two-phase cooling, but ultimately cold plate, which is direct to chip cooling, is the trend, is the main trend right now. 99% of liquid cooling today is direct to chip cold plate cooling, which is industry standard. And you're going to have no problem sourcing supply chain. You're going to have no problem having design, because a lot of standardized design, server-wise, rack-wise, ORV3 racks are very standard in the world right now. Even power side, 800 volts DC is becoming a norm in the industry for cold plate cooling. If we go to others like immersion cooling, two-phase, precision cooling, some sort of hybrid solutions are all options, okay? Quickly mention about immersion. Immersion is really great for extreme high densities, high complexities, and you need to have a lot of more fluid management because essentially the fluid is dielectric fluid, right? Ultimately, three things to remember, whichever cooling solution you're trying to adopt. First one is material compatibility, which equals to material warranty. you have to select carefully, making sure that, seals, gaskets, metals, pumps, QCDs are fit for purpose. Maintenance, operation, services, as I mentioned earlier. Last but not least, it goes back to scale. Are you trying to build once and for all, or do you want to go for scale? So once you go for scale, then the design aspects is different. You need to consider your floor weight, your space. So all that needs to be a sort of a consideration.
Fantastic. Peter, it's been an absolute pleasure speaking to you, and I'm amazed at how much you've packed in the last 20 minutes. I'm interested to know, for those, and also myself, who'll be interested to read up a little bit more about BP Castrol and what you're currently up to in the market, where can we check you out?
We basically attend every global trade shows, IT events. You can read about us in DCD. DCW events, we go there. I wanted to just quickly end on one note is there's not one company that doesn't do it all. Okay. We just have to play it. This is an ecosystem play that we are all part of it. For Castrol and BP, we try to be very diverse in terms of business model. Okay. For example, leasing models, performance models, contracting models, can all be discussed, okay? And we probably is the only fluid provider that's able to provide fluid warranty. We're able to give warranty to the fluids. That's how confident we are in terms of our technology. But yeah, well, welcome to visit us, and happy to continue talking in DCD.
Fantastic. Well, Peter, thank you again, and to the team at BP Castrol for coming on and sharing your insights. And to our audience, thank you so much for tuning in. You can also search this video using our AI searchability feature and our chapters if you want to find anything in particular. But also, please do reach out to BP Castrol, Peter, and the wider team. I know they'd love to hear from you. For now, that's all we have time for, and we look forward to seeing you at the next DCD talk. Thank you.